Supposedly, if you have the demand function q is equal to 5 p to the power a, you have this demand function. Now, in order to compute the marginal revenue function, what we'll have to do is that you'll have to first of all solve for p. So how will you do that? I'll write this as q by 5 equals to p to the power a. Fine. And then I'll write this as q by 5 to the power 1 by a equals to p. Fine. So this is your function. Fine. So this could be actually written as, yeah, this is your function. Where can I simplify this? Yes, I think I can, because I can write this as q to the power 1 by a upon 5 to the power 1 by a is equal to p. So say 1 by 5 to the power 1 by a as equal to anything, whatever, so c. So I can write this as p is equal to c q to the power 1 by a. This is your demand function. Now I can write this as what will be my total revenue function? P into q, which will be c q to the power 1 by a into q. Fine. So this will be c q to the power 1 plus 1 by a, which should be c to the power q, sorry, c into q to the power a plus 1 by a. This is your TR function. Now, in case if I want to differentiate, in case if I want to find out the marginal revenue function, this will be dtr by dq. So that would be a plus 1 by a into c into q to the power a plus 1 by a minus 1. So simplifying this further, you'll be getting a plus 1 by a into c into q to the power a plus 1 minus a to the power a. A will get cancelled out, and you will have 1 plus 1 by a into c into q to the power 1 by a. This is your marginal revenue function. Okay. Now, this is your marginal revenue function. I'll just write it more properly for you guys. MR is 1 plus 1 upon A into C into Q to the power 1 upon A. P is C Q to the power 1 upon A. This is your demand function. This is your MR function. Fine. Now, you can take up different values of elasticity. Fine. One more thing. You know what this function is like? In case if you look at this function, this A is nothing but the elasticity. How? Let me just tell you. You have, I just show it here. Q is equal to 5p to the power a. Fine. So your elasticity of demand is p upon q into dq by dp. So what is dq by dp? It is a 5 to the power into p to the power a minus 1. This is dq by dp. Substitute it here into this function. So what will you get is P upon Q. In place of Q, you can write 5p to the power A into A 5 to the power 5 into p to the power A minus 1. This is what you will be getting. Simplifying this, you will be getting P upon 5p to the power 5 into p to the power A into 5p to the power A upon p. I can write this as upon p because p to the power A minus 1 is p to the power A upon p. Now this p will get cancelled out. 5p to the power A, 5p to the power A will get cancelled out. What you will have is just A. So this is your elasticity. This is your elasticity. This is constant elasticity function. Now, in case if elasticity, which is nothing but equal to A, this is equal to say minus 2. And then in that case, your MR would be 1 plus 1 upon minus 2 into C into Q to the power 1 upon minus 2. So simplifying this, you'll be getting 1 minus 1 by 2 is 1 by 2 into C into Q to the power minus 1 by 2. Okay, so simplifying this, you will have C upon 2 Q to the power 1 by 2. This is your MR function. Demand function would be C into Q to the power minus 1 by 2. So C upon Q to the power 1 by 2. So your MR function, this is your MR function, this is your demand function. So MR function, as you could see, it is just half of P. Fine. So in case if we take up little more elastic case, let us take some more elastic case when A is equal to minus 5. So in this case, your MR becomes 1 minus 1 upon 5 or 1 plus 1 upon minus 5 into CQ to the power 1 upon minus 5. So that would become minus 5 plus 1, 4. So it is this is minus 4 by 5 C Q to the power minus 1 by 5, or it is minus 4 by 5 C upon Q to the power 1 by 5. So this is something like, just wait, your P is C into Q to the power minus 1 by 5. So P is C upon Q to the power 1 by 5. So this is something like your MR is basically 0.8 of P. So what happens is that the MR curve approaches the demand curve. Okay, MR is almost becoming demand. You pick up A equals to minus 10 and then you will see that MR has become now 90% of the demand curve. So MR curve approaches the demand curve as demand becomes more elastic. As your demand curve is getting more elastic, we have seen the case when A is equal to minus 2, then we have seen the case A equals to minus 5, and then when A equals to minus 10 and so on. So demand is getting more elastic. As demand is becoming more elastic, MR curve is approaching the demand curve. Okay, and in case if A is equal to minus infinity, then what will happen? MR curve would actually become P. Okay, in that case MR would be equal to price, and that is the case of infinitely elastic demand, in which that is particularly the case of perfect competition, in which the firm is a price taker. Okay, fine. So this was an application of the relationship between the MR and the elasticity of demand.